So you have an example. I am not going to do the motor circuits in this. I am going to do the charge relay. Okay, and then from there, hopefully you know enough to be dangerous to complete the other ones. All right, so this is my diagram for the charge relay. And the first thing I'm going to do is identify what components out of this diagram the charge relay is associated with. Okay, so what components do I need for the charge relay to happen? I need the charge relay. That's pretty obvious, right? So we use charge relay. What else is working? Yep, jump all at once. Charge light. That little blue light's supposed to come on, so I know that's going to work. What else needs to be here for the charge relay to operate?
The charge socket.
Right, you have to have that plug-in in. Okay, those are the basics. And then from there, I know that this fuse block is going to work because looking at it, I can tell that 12 volts are running to that fuse block. And then from there, if I go backwards, the big red button down to 12. Okay. Next step is what needs to be doing what. I'm going to start at the top of this. The charge socket has to have a connection from the neutral to the ground. There has to be a wire that jumps those two positions. Now, in your setup, it is set up so that the grounding wire is also connected to what's called the neutral wire and the hot wire in that plug. Okay, if we take the plug apart, you'll see how it's wired up. This plug is wired up according to alternating current rules. With alternating current, you have hot, neutral, ground. In DC terms, we're dealing basically with hot. We're dealing with positive and negative. So we have two different things going on. Anyway, there needs to be a connection between these two pins for the circuit to work. All right. When this circuit is operating, is the charge light on or off? The charge light is on, right? It glows, so that means it's on. The charge relay, when this relay is operating, there is power flowing through pin 85 to pin 86. Okay, if I am looking at relay pins, for lack of a better word, okay, 85 and 86 both deal with the coil. And if I remember right, 85 is coil plus or coil positive, and 86 is coil negative. Okay. Coil plus, coil minus. And I did, but I don't see it in front of me right now, have a clear one that kind of shows that, but I don't see it right in front of me. So there has to be power going through pin 85 to pin 86. That energizes the coil. All right, if I take a look at these guys, 87 and 87A, that is the same switch with two possible outcomes. And it's one or the other. It's never neither. And if it is neither, then the switch is broken. All right, pin 87 is a normally open switch. So when there is no power running through it, that's what it means. It is normally open. So that the switch when the coil is shut off, that's the position of the switch, my bad. like that. Okay. 87A is normally closed. So when there's no power running through the coil, that's the position of the switch. The last one is 30, which is the common. And all the electricity goes in, or all the electricity goes out on common. And I think in this particular lab we have examples of both. So if I turn the coil on, this switch will move to that position. All right, so when we see these things normally closed, normally open, we're talking about, is the coil off or is the coil on? All the electricity enters or leaves on pin 30, or the common, and then pin 87A is normally closed. Pin 87 is normally open. Clear as mud. Okay. Now, if I'm going to route the 12 volt power around, because I have to reposition my camera now, I'm going to start out at 12 volts to the big red button. Now, in order for this circuit to work, does this switch need to be closed or open? On or off? Does the switch need to be closed or open? Closed meaning the switch is making contact. Open means they're apart and separated by air. Electricity can flow through a switch if the switch is closed. So is this switch closed or open to get the circuit to work? It is closed. So I'm just going to mark that as closed. Okay. And then that means the electricity is going to go up to the always on block, correct?
We can't see what you're doing.
Because I am doing the wrong diagram. I'm sorry. Closed. All right. Power comes through the switch because it's closed, comes up to the always on fuse block and goes through, right? So it's feeding pin 85. It's feeding pin 30. And we have to and it is also feeding this bottom one here, the key relay. So 12 volt from the battery or the power source through the big red button up to the always on fuse block, and I have traced where the electricity is flowing as it leaves the fuse block, because the fuse block does not switch. It's a safety device. Okay, in order for the blue light to turn on to indicate charge, which pin on that relay carries electricity? 87. So I'm going to highlight 87. Now, in order for pin 87 to operate, Does the coil need to be on or off? Pin 87 is normally open. So do I need to have the coil operating or not operating? On or off? Yes, you need to have it on. Okay, so that charge relay is going to be on. So I put a little jumper there to show me that. In order for this switch to work, I have to have pin 87 and 30 connect. That means normally open. Now if I follow my electricity around through the fuse block, 85 is on. That moves the switch from normally closed to normally open. So what is feeding pin number 30 can feed through pin 87 up to the light. Correct. 87A is not being used. The relay will operate 87 or 87A. It will not operate both. So if it's operating on 87, it cannot operate 87A. It's basically done. Okay? Since the charge relay is running, that means 87A is not operating, so there is no electricity going to the key switch. It is not operating, so I don't need to take care of that. And even though there is electricity running to the key relay, since the key relay has to have the key switch in order to operate, it's not going to do anything either because the key switch depends on 87A, which is not doing anything. Because the way a relay works, it selects between 87 and 87A, never both. If it does, we have problems. All right, so my 12 volt positive is taken care of. Now I need to lay in what my negatives are. So if power is going to 85, that means it's operating the coil, and that means 86 is acting as its ground. So I'm going to highlight number 86 as a different color. Up to the charge socket, that charge socket is making a connection. Right there. My last ground I need is that I need a ground connection in order for the light to operate. And that's how you diagram that charge circuit. What you will work on is figuring out the electrical flow for the motor circuit. Okay, the first one is, if I'm going to do the motor circuit, all right, and I'm going to try to label these things so I kind of know what's what, all right, this guy is going forward, and sometimes you'll see a clockwise arrow along with it. All right, so if the motor is turning forward, let's try to work backwards a bit to see what components need to be operating. Okay, backwards from the motor. Well, I'm going to guess it's the forward relay. Does the forward relay need to be closed or open in order for it to work? Okay, so it's going to need to be closed. And I'll put parentheses on for that. All right. The next component in the system is probably going to be the switch. Okay. So the switch would need to be set in the forward position. And that's going to tell me which set of pins I'm using. Am I using pin 6, 3, 1, a combination of? What are pins 5 and 2 doing in there? That sort of thing. Okay, to help you get started, pins 2 and 1 have to connect for this motor to run forward. Pins 2 and 1 have to connect. All right. Are we using the key-on fuse block? Yes. Is it on or off? It's on, but it's a fuse block, so there's no switching on and off. It's just wired into the system. If electricity is flowing through it, it will just flow through. Okay, if the power is on, I should say. The inertia switch or the crash switch, the bumper switch sometimes. Does this need to be closed or open to make the circuit work? Okay, if I follow the path around, it's hooked up to the key switch and it's hooked up eventually to the key relay. Does the inertia switch need to be closed so electricity can flow through it, or does it need to be open so it does not? It does need to be closed. All right, and every one of your vehicles has one of these somewhere, someplace. It might be tucked behind the bumper. It might be up against the front end of the car along the frame rail. It might be up against what's called the firewall. That's the wall between the cabin and the engine. And the whole purpose of that thing is that if the vehicle bumps into something, it opens up and shuts the fuel pump off. So that if you're in a crash bad enough to tear a fuel line, the fuel pump won't keep pumping fuel. Okay? In this situation with an EV, that inertia switch hits something and opens up, then it's going to shut power off to the drive system of the car. That's what this is supposed to show us. Okay. Always on fuse block is always on if it's getting power. And then what about the big red button? Would that need to be closed or open to make these circuits operate? It would have to be closed. So just like I have it here. Key switch. Closed or open? Closed or open? It would have to be closed. Those contacts have to hit each other, so it would be closed. Kind of like that. And then the run light. Would the run light be on or off?
On.
Yep. Because it's going to shine. All right. So these are the components that are going to be used in the circuit. We've gone through and figured out if they're closed or open, on or off, and then using two different highlighters. Use one highlighter to show where the 12 volts are flowing. Use the other highlighter to show what the grounding path is. In order for these circuits to work, there has to be both. All right, and I'm only interested in these to see where the electricity is flowing. So I'm not worried about the reverse circuit on the first diagram, and I'm not worried about the charge socket. I'm only interested on what's happening with the forward motor. At the bottom of the page is the same thing except going in reverse. So what things, and again, what's 12 volt, what's ground? Some of the components are going to be used again, such as the key switch. That's pretty obvious. But where's the 12 volts going? and where are the grounds going in these two switches. Plus the questions, I think there's 9 questions on Schoology. This is due at the end of the week. So if you want to work it on it now, yay. If you work on it for today and decide that you want to work on the car, because we're still working on inventory tomorrow, and work on this outside of class or something along that line, that's fine. I'm going to leave that completely up to you. But I want to put grades in the grade book for this weekend, so I would need this by Thursday at 3:15 or so. Okay, there you go. That's the next assignment that we're working on then.